Welcome to Zero Knowledge, a podcast where we explore the latest in blockchain technology and the decentralized web. The show is hosted by me, Anna.
And me, Frederick. In this episode, we'll sit down with Gavin Wood to talk about Polkadot, some Ethereum sharding history, and what Substrate is.
So before we start this episode, we just wanted to let you know about an upcoming event called the Web3 Summit, happening in Berlin from October 22nd through 24th. Both Frederick and I will be on site, and we'll be organizing a meetup for the Zero Knowledge community. So please keep your eye on our Twitter at Zero Knowledge FM, and if you're around, come say hi. So I hope to see you there. Now here's our interview with Gavin.
Hello, everyone, and welcome back, Gavin Wood, to this show. For those who don't know, Gavin is the founder and CTO of Ethereum, or was, and he's the founder of Parity, and is now working on a new project called Polkadot. Super happy to sit down with you again.
Thanks for having me.
Hi, Gavin. So we know you pretty well, but we're really excited to have you back on. So far in the podcast, we've mentioned Polkadot a couple times, so we now have a chance to actually set the scene for Polkadot. So I think to start, I'm definitely curious, where did Polkadot come from?
Well, the backstory to Polkadot, I guess, is relatively nebulous. The beginnings of it were basically my considerations for scaling out Ethereum, which I started thinking about in sort of mid to late 2014. Now, after leaving the Ethereum Foundation, I was very heavily involved in development for the Parity Ethereum client, and not thinking so much about sort of next generation protocols or scaling or anything like that. I was pretty focused on just making sure we made Ethereum as well as we could. But around mid 2016, once the Parity Ethereum client had hit 1.0, and we were relatively happy with the progress on that, it sort of came to the forefront of my mind, and I started thinking about how Ethereum might scale eventually. Now, this was something that was meant to be in development for late 2015 and much of 2016. And as someone who was sort of taking part in the core dev calls at the time, where we were discussing, what was going to happen with Ethereum and all of the sort of ideas and really looking for, in some sense, technical leadership from the Ethereum research team. We were getting relatively sort of a lot of, how would I put it? Interesting ideas were coming, but relatively little concrete specifications or descriptions of what the final solution will be was being handed over to us. So it was at this point I started thinking, right, well, sooner or later Parity is going to have to start creating something that is a scalable version of Ethereum, and it's going to be sort of with or without the foundation's help. So that's basically when I started thinking about what would become Polkadot. Now, in late summer of 2016, I was in San Francisco with another guy from Parity, Marek Kotovich. And, we were sort of chatting about, how cool, sort of Parity Ethereum was and how cool it would be to sort of build on it and what the next generation of the Ethereum protocol was going to look like. And I was sort of talking about some of the directions that the Ethereum Foundation guys were going in, what Vlad was talking about, what Vitalik was talking about, what I had sort of put forward in a couple of years before. And we actually met with Jay Kwon as well from Cosmos at the time, who was sort of describing what Cosmos looked like. Then I think it was called something else like GNU or some significantly worse name. And we over the next day or two, we were sort of hanging around in San Francisco. I think there was a particular cafe that we spent, or bar or something, that we spent a few hours at. I forget where it was exactly. Where basically we put together what would become Polkadot. And it was, we took ideas sort of, that had been on the back burner, And really it was like, right, how do we do this? How do we make a scalable Ethereum? If we want to do it as quickly, as simply, and as speedily, as quickly as possible, then, let's just think about how we would do it. So, Polkadot, or at least a sort of proto Polkadot, came from that. And what Polkadot was a realization on top of that actually this framework that I've just sort of described, it doesn't require the individual chains to be all of the same type. They don't all have to be shards of Ethereum. They can actually, in principle, be any kind of chain.
One question here, was sharding already proposed at this point?
The idea of, splitting up the Ethereum state into many different pieces and processing them in parallel in some way was sort of, really, it was around since day one of Ethereum. It was like, this is where Ethereum will go eventually. But the specific idea of how it was going to happen, like technically speaking, and how the game theory was going to make sure that, no validators could ever possibly attack the network, that was still really hasn't been ironed out. It really hasn't been nailed down at all. So yeah, we're talking like 2 years ago when, basically it was like the Polkadot paper, was being discussed.
In these meetings, so you were in the Ethereum core dev calls. Was there a frustration a little bit? Kind of like a sense of like, I want to go faster.
Definitely from our side, from Parity, and certainly from my side. Yeah, we're getting fed up of waiting, This is what the Ethereum research guys were meant to be delivering, and there was relatively little the appearance of progress. Now, I'm sure if you sort of dive deeper into it, there was progress happening behind the scenes. Ideas were being tried, there were people thinking about it, there were sort of, to and fro, as is often the case with creativity. But from our point of view, it was time to get moving, guys. And if you weren't going to sort of tell us what to do, then we're going to go ahead and figure it out for ourselves.
I think that's always like when you're talking about research and in general, when you're trying to come up with a solution to a problem in that way, it's exactly what you say. Like, it's not that there's not progress, but you kind of think of something new and say, oh, this would actually be a better solution to this piece, or this would be better here. And then you kind of, this tired old quote of like, perfect is the enemy of good, where you kind of just keep chasing the perfect solution and you kind of never actually do anything. One of my old bosses, I once went to him and said, like, I'm implementing this thing, or I'm trying to implement this thing, and I can't like figure out what the perfect solution here is. Like before, like on paper, before I start writing code, like what should I do? What do you think is the best solution? And he was like, why are you even thinking about this? Just start writing code, and eventually you get to something that works.
From the hip, shoot from the hip, all the way.
So there's like these two like extremes. Either, don't think about anything, just write code, or try to think about everything and never write code. So obviously you have to put yourself somewhere in between.
Do you think also though, like in that scenario, there's so many constraints, right? Like these proposals are made, but you're kind of you're dealing with an existing protocol, with something that has its definitions, limitations. I feel like if you're in one of these kind of conversations, it's obviously going to be a lot harder to really implement something into an existing thing than to be able to start from scratch. And that's basically what you guys did.
Yeah, it's absolutely true. And I've always been fairly clear that, upgrading any system in situ is really hard. Upgrading a decentralized system in situ is like nearly impossible. So, I don't want to dismiss in any way, the efforts of other people, particularly within Ethereum, but it was simply a reflection of our own, mindset at the time. We'd implemented a bunch of stuff. We were ready for the next chapter, and the next chapter hadn't been written. So it was up to us to pick up the pen.
So to recap, it was actually sort of a solution to the Ethereum sharding problem, scaling problem, whatever you want to call it. And you kind of made this protocol, this idea, but then added the additional abstraction on top that each shard can be different from the other one. Even today, when we're talking about Ethereum sharding, they're talking about all shards being homogeneous. So they're all the same and they're all running the same VM and the same kind of model. Was there any complication in adding that abstraction on top? Did you have to like significantly rethink anything in how you'd like thought of this protocol?
Not at all. In fact, it was just a logical implication of the protocol as it was that was meant to be just a sharded variant of Ethereum. Basically, we sort of worked out the game theory, worked out the various actors, and there was a little bit in it that said, right, this is where this actor should check that this block is actually a valid Ethereum block. And then it was like, right, well, actually, hold on. If all they're doing is checking that this block is a valid Ethereum block, then we can just switch out the is a valid Ethereum block bit for is a valid block of blockchain X. And it was as simple as that.
So you have this idea. You're in San Francisco. You're chatting with Merrick. What happens after that? You have this idea for this protocol. Was it like you sat down one day and was like, here it is. And you wrote it out and it was done? Or was it kind of like you had to go over it a few times, you had to refine it? How did that go? How was that part?
So I think the key elements of the idea were basically in place in that bar that time in San Francisco. There was really nothing significant that was added to the protocol itself. After that, a guy called Wendell Davis arrived in San Francisco, and we met up with him. We sort of told him, yeah, we got this kind of cool idea. What do you think? And he was like, yeah, this is a cool idea. You should do it. As it turned out, sort of Wendell ended up helping out the Amise Go guys, and his time is relatively limited. But otherwise, I think he would have been, there were sort of vague ideas that he was going to help out with the project. Beyond that, really, it was a case of flying back to Berlin, setting aside a week or two, and just bashing out this paper that basically said, had all of the bits in it. But I think it's worth pointing that, yeah, when I was sort of typing out the paper, there were refinements that got in there. Part of the refinements were certainly in the direction of governance. Perhaps not sort of what we think of governance, but the technical foundations of the governance. Specifically, this idea that the parachains would be defined in terms of WebAssembly, which is now fairly central to Polkadot, to the project, and also in some sense that the relay chain itself would also be defined in terms of WebAssembly. And of course, the name at the time it was called something else. It went through 3 or 4.
Can
names.
you tell us what some of the previous names are? Will you admit it on air?
Actually, one of the first name was called Disparity, which I quite liked because it was like disparate chains, right?
Yeah.
Like many disparate chains. And it was obviously tied into the branding. But yeah, after consulting a few people on that, it was considered a little too negative. I think a later one was Interplex. I went as far as to buy the domain for that, but that's a little blends into the background of the aeons, cosmos, eternity, definity, sort of math-fi.
Sounds a little 90s to me.
Yeah. So I'm pretty happy. Polkadot actually arose through the paper. So I wrote the paper, and I've written the yellow paper before. And there was already like a beige paper and a red paper and an orange paper and whatnot. So the colours had been done as far as I was concerned. So I wondered what was next. Of course, patterns are next. Once you've had colours, you move on to patterns, and it's like, so I could have like, I don't know. The stripe paper. But stripe's already associated with the finance world, right? So it was the obvious, Polkadot's fun, right? So.
And it fits.
You have
parachains. You have these little...
You can make it fit in a retrospective construction. So you touched a little bit on governance there. I was curious if that was always part of the construction. And I like that you separated it a little bit as well. I've heard the term technical governance used before. I quite like that term. There's human governance and organizing people around a cause. And there's technical governance. How do you actually implement a change on a chain, for instance? Was that always part of the idea, or was that something that came out of frustration with being unable to change Ethereum, or where did that come from?
2 main directions, possibly 3. So first was the DAO. So the DAO, bit of a disaster there. I'm a little impressed that we actually managed to make a rescue attempt. I mean, we did end up with Ethereum Classic. But I'm fairly impressed that it worked out the way it did. But any way to ensure that if 90% or even 70% of a community sort of feels some particular way about something, that should be able to be expressed and enacted in a automated but decentralized fashion, I think is good. Then there was the Ethereum hard forks. So rolling out a hard fork is a pain in the ass. We're seeing that even more so these days with sharding and Casper and a few other sort of technical improvements to Ethereum.
And to be clear, like, this is just what most people, or like Zcash people or whatever, would call network upgrades. They're not like contentious hard forks or like trying to split the chain or anything. Just upgrades.
Yeah, that's right. So basically non-controversial technical alterations to make it better. And these are often kind of risky, operationally heavy, communications heavy operations that are very difficult to organize, and people's general aversion to such things, because of course most of the people behind this are developers who are not generally the best people in the world at communications or organization or operations. And so the reluctance to actually do anything about hard forks is resulting in a lack of innovation. And we see it, sort of maxed out, with Bitcoin, but that sort of inertia, is also feeding its way into Ethereum. Mm-hmm. And I wanted this chain to be able to avoid that. So that was the second thing. The third one, I guess, something that's always been in the back of my mind. This little, let me cast my mind back. So it's March 2014, and Vitalik and me are doing an Ethereum meetup in Silicon Valley, and there's, I don't know, maybe 40 people there, and we're basically just sort of describing what it is that we're planning on doing, and look, we've got like a vague proof of concept, and isn't it cool? And we get to the end of the talk, and some guy with a Stanford T-shirt, very. It reminded me a bit. There's a film that George Clooney was in called something, and there was a girl, and he was after the girl, and the girl had a father who was in the FBI, and the girl brought home a boyfriend that was sort of George Clooney's love competitor. And the boyfriend was obviously a bit stupid, and he had a T-shirt on with massive letters FBI, and the dad was like, is that what you wear on your undercover? This kind of reminded me a little bit of that. Anyway,
this was the Stanford version. Right. He just really wanted you to know.
Exactly. It was an older guy, and he stood up, and this is like basically the first time. And, I've done a few public talks, and this was the first time, and only time, that, someone from the audience has given me such a hard time on a question. And his question was, how do you upgrade it? This idea is great, but how, it's not going to last forever. And when you want to upgrade it, how do you upgrade it? And the answer was, well, people upgrade. You download the new version, and there's a block number, and then you upgrade. And he was like, yeah, well, that's not going to work, is it? And at the time, I was like, of course it'll work, it'll be fine. In some sense, it was fine. It happened a couple of times now. We've done 3-4 hard forks. But he absolutely had a point, which was that it's not easy. And it could definitely be improved. And at the time, we didn't have an answer for him because there was no really, WebAssembly wasn't around. There was a few a couple of precursors to WebAssembly, but they weren't really at, the capacity that we could do what we wanted to do with them. There was LLVM, but again, it wasn't an acceptable solution for this. It had numerous drawbacks. So really, there wasn't a technical solution. And whereas I should have said, yes, that's a good point, I actually tried to sort of make him understand that an upgrade path, an upgrade mechanism wasn't necessary. And of course, it fell on deaf ears, but also, I was definitely downplaying it too much.
You didn't realize at the time that Stanford dude was actually predicting some of the future.
Indeed. Now, he was, as it turned out, he wasn't actually a Stanford dude. He was just a dude who quite liked the idea of going to Stanford or having gone to Stanford. And I think, he just got the T-shirt from a friend. But nonetheless, he had a good point. And that has sort of been in the back of my mind for some time, because as I said, it was the only time we were like arguing back and forth for what must have been 5 or 6 minutes, which in a meetup is a fairly sizable chunk of time, to be, focused on a single point that you don't really agree on. And it did stick in my mind. And I think, this is almost my way of saying, fair cop. We're getting to it now.
Nice. So this is funny because I actually have a question sort of related to this. I was wondering what the best question you've been asked about Polkadot is.
Well, I don't answer meta questions on principle. So I'm just going to throw it back at you. And that was the very best question I've been asked about Polkadot.
Damn it. Also, maybe you don't know right now what the best question was on Polkadot, and you'll find out 2 years later.
Yeah, maybe.
So digging in a little bit more on the technical side of like what the protocol actually is, can you give a high level view of just like what the players are in this network and what their roles are?
Sure. Well, the Polkadot paper mentioned 4 distinct roles for the people that maintain Polkadot. So there was the validators, the nominators, the collators, and the fishermen. In the, let's say, revised model, in some sense, it's still correct, and you can, if you want, split things into these 4 groups. But I actually prefer to meld together the validators and the nominators, because they basically fulfill more or less the same role, and meld together the collators and the fishermen, because basically being a collator implies you're a fisherman. And it seems unlikely that someone would choose explicitly to be one and not the other. It's a relatively minor configuration point. So, in the sort of new model, there's really just validators and collators. And validators, the main difference between them is that validators sit on the relay chain. So they maintain a single chain. They keep synced to that chain, looking at the blocks, and they're helping create new blocks. And the collators are sitting on a parachain. So they don't sit on the relay chain, at least not as a full node, perhaps as a light client. And they look out for new blocks on the parachain, and they basically help putting together.
Just to clarify, like in Ethereum sharding terms, a parachain would be a shard, and the relay chain would be like what they call the beacon chain or whatever. So it's like one central chain, and then a parachain is like a shard. But it doesn't have to look like the other shards.
That's actually, I was curious about that. Like in the Polkadot protocol, is there a center? There's a central blockchain with parachains coming off of it?
Yeah. So the relay chain is what you might call at the center.
Okay.
So it's, it sits and it has, it validates a bunch of other chains, parachains that are, that control their own state, but they do so under the rules that they set themselves to the relay chain. So the relay chain is like this neutral third party that basically keeps the parachain at its word. So if the parachain wants to do something that it's not really allowed, that's against the rules that it set up for itself, it's the relay chain that says no. It's against your rules.
Is the relay chain where the security lies too?
That's right.
I have a question now about the individual roles. So you mentioned, so now there's more like 2. Mm-hmm. So if you look in the context of like nodes, would that be individual nodes making a decision about which role they take? Or would a single node take on many roles? I'm just curious where those roles really live.
It's really about actors rather than nodes. For example, an actor who wanted to be a parachain collator. So maybe let's imagine there's a parachain called WebChain, just to pick a name out of the air. So there's a parachain called WebChain, and I want to be a WebChain collator because I'm going to get paid in WebChain tokens. Then I will run a full client, a full node on web chain, the parachain.
Okay.
And running that, I will probably also, because I want to be a collator, I will also have to run a light node, light client on the relay chain. Because I have to know what's going on the relay chain to know when it's my, I have to know what's going on, just a part of the sort of technicals. So, I'm actually running two sort of nodes. I'm running a light node and a full node. If I'm just a validator on the relay chain, then I just run a full node of the relay chain. So it doesn't make sense really to talk in terms of nodes, but it does make sense to talk in terms of actors. It's quite reasonable that you will get a large actor who runs multiple nodes. So maybe runs a single, maybe runs a full node on the relay chain because they want to be a validator, but they've got so many tokens and so much power, and they've got so many Amazon instances. They also run full nodes for 50 parachains, and they're producing all of this, all these blocks, and it's all good.
Would they have to also run, you sort of mentioned the light clients, would they have to have a light client for each one of those parachains?
Implementation detail, but I would hope not. At least in, possibly in version 1.0, I would hope not by the time we get to version 1.
Gotcha.
We touched a little bit on the sort of governance aspect of this already, saying that, they run WebAssembly. But how do they actually run WebAssembly? Where does this... I know the nomenclature, so it's sort of like obvious to me, but we're talking about runtimes for a blockchain. I don't know if that makes sense to everyone, though. So you would essentially have... you define your blockchain in some code, and then that compiles to WebAssembly. This is your runtime. But what are these runtimes actually doing? Like, how does this WebAssembly piece work?
So you can split a blockchain up into two components, if you like. Two sets of logic. One of the components looks after things like ensuring that the blockchain has peers, that the node has peers, I should say. Ensuring that there's a database, so it can store stuff from block to block or from instance to instance. Ensuring that there's the logic to be able to synchronize that database when it connects to other peers. And ensuring that there's appropriate logic to author new blocks, and critically, to be able to recognize correctly authored other people's blocks. So if your synchronization code says, yeah, we've got all these blocks coming in, it looks great, then you need a bit of logic that says, it might look great, but these are not the blocks of our chain, or they are the blocks of our chain, but they're not the blocks of our specific bit of the chain that we're interested in. They might be badly finalized blocks, so they might be like malicious validators, they might be double signed, or they might just be a part of the sort of a chain that has fallen by the wayside, a stale fork, as they say. So that's one part. One part is looking after the construction and maintenance of the chain. So it's either you're making your own blocks or you're looking for blocks from other people, and you're creating this sort of chain. The other part is looking after what it means for those blocks to have happened. So in Bitcoin, to take a simple example, what it means for, some transaction outputs to be spent is that some balance has moved from being able to be accessed by one key or set of keys to being able to be accessed by some other conditions, which is probably keys or set of keys. That's what makes Bitcoin Bitcoin and not Ethereum. With Ethereum, most of it remains the same. All of the stuff that I just described, synchronization strategies, working out whether it's the canonical chain, the right chain, or whether it's something that just fell by the wayside. It's all the same, pretty much. There are one or two minor details that have changed, but it's very much the same thing. But the bit that works out how the transactions, what they mean, right, how they change things, that's different. That's very, very different. And that's why Ethereum is a smart contract platform and Bitcoin is a currency. Well, the runtime is that bit that is different. The bit that makes Ethereum a smart contract platform and Bitcoin a currency. That second bit that I described, that's the runtime. We could also call it, if we're being very technical and strict and academic, we also call it the state transition function, right? Because it's the function, the bit of logic, the definition that defines how the state transitions from one block or one transaction to a new block.
We're talking about the state database.
Well, the state database is part of that database layer on like how you actually store this. But basically how you update that state database is defined by the state transition function.
Yeah. Okay.
That's right. So your blockchains pretty much are the model, if you like, the computation model. So if you were describing this to someone from the 60s and, they just wanted, tell me what a blockchain is. And you wanted to describe them at a relatively high level. Well, the model is there's some storage, which is a database, key value database, pretty much. Ethereum's a little bit more complicated because the keys are actually account IDs and the values are actually balances, like transaction counts and other trees of key value pairs. But by and large, there is some structured state or database or storage that sticks around between blocks. And there is some code that takes your block, which is basically just a bunch of transactions, and your previous storage, and just tells you what the new storage is, or it's invalid. So either says, no, it's invalid, no good, or it says, yep, it's valid, and here is the new storage. And that's what you put in your database. And it's as simple as that.
So how does governance fit into the state transition function?
Well, governance is a bit of an umbrella term. So there are two bits that are useful to talk about with governance. So the one is the sort of underlying fundamental reason why governance, and particularly binding governance, is even possible. And the other one is the specific mechanisms under which people or actors in the system can govern. Like how do they actually have their decisions be made? So one of them is about enacting decisions. The other one is about making decisions. So I'll do the enacting decisions first because it's easier and it's closer to what we've been talking about. So enacting decisions is about the WebAssembly. So basically it's saying, right, well, the key thing about governance is, firstly, it should be possible to alter the database in some way that we cannot foresee, because it might get into some state that we don't mean it to go into. For example, there might be a DAO, and it turns out that the DAO has like completely locked up a bunch of money and it's going to be stolen if we don't do anything for 30 days. And we really want to alter the database so the DAO has no money. And in fact, the DAO doesn't exist. And everyone that put money in the DAO has got their money back. Mm-hmm. So it's a completely arbitrary alteration. There's no real way of encoding this alteration up front. We just have to be able to say, well, under certain circumstances, we need to be able to alter it in some arbitrary way. The other thing that we want to do is we want to say, well, look, we've got this cool technical improvement and we need to deploy it, which basically means changing this function, this runtime, this state transition function. And we don't know what we're going to do up front, inevitably, and there's no real way of ever being able to say, well, this is a non-controversial agreement and this is a controversial, it's like, no. There is either you're going to upgrade your state transition function or your runtime or you're not. And so it's useful to be able to do that. And, that's the other thing that WebAssembly makes possible. So by having this general, format for expressing the runtime logic, we can, allow for that to be altered arbitrarily down the line. So it's Turing complete, the lovely Turing complete phrase. It basically means anything that we can think of down the line, we can replace it with that.
In current Ethereum setup, it's not like that.
No, so in the current Ethereum setup, it is what programmers would call hard-coded. So, there is the Ethereum specification, the protocol, and they implement that. And that protocol there's no way of that protocol changing itself. Whereas with Polkadot, the protocol is self-describing. So the Genesis block, this is like very cool and beautiful sort of thing for the mathematician inside of you. With Ethereum, the Genesis block included the balances of various people that had taken part in the crowd sale. So the Genesis block is this kind of initialization data that goes into the storage or the database of the blockchain, the state of the blockchain, if you like. The Genesis block of Polkadot includes Polkadot, right? So the Genesis block of Polkadot includes an entry in there that goes under the label code, And that is the code of Polkadot, of the Polkadot runtime. So that describes Polkadot's state transition function. And that's the code that gets queried every time a new block comes in to say, hey, is this block actually a valid Polkadot block? And if so, could you tell me how it changes the state? And then it's the Polkadot client that looks at the result of that and decides, hey, okay, that was a good Polkadot block. I'm putting it in the database. I'm going to change the state in this way, or that was invalid. And the person that gave it to me, I'm going to punish them. Now, at the moment, there aren't really any other blockchains that do it. So Tezos sort of wants to do it, and they've got something that's sort of similar in their roadmap. But in principle, at least, this idea of abstracting the state transition function and encoding it in some Turing complete general fashion and sticking it on the chain itself, that's a new thing.
And that's what enables, basically having that code on the chain itself is what enables upgrading it, because you can just issue a transaction that basically says, okay, replace the code with this version of the code, which is a complete representation of the runtime. And then after that block, you are now running on the new runtime.
Would the fear then, though, be what happens if you do one of these upgrades and it's like kind of taking you in the wrong direction? Does this open up like the door to a malicious actor doing something, or what's the problem with it?
Inevitably, it is a powerful mechanism and must be tempered with an appropriate means of governing when these upgrades should happen.
So that leads to the second part that you were talking about before.
That's right. So aside from potential bugs, now if there are potential bugs, you can't really prevent bugs. You can do your best to make sure they don't get in. One way of doing that is by formally specifying the specific mechanism by which upgrades should be able to be allowed, and then making sure that multiple people, when they implement that mechanism, they end up with roughly the same. Well, they end up with something that results in the same thing. So you can have multiple implementations. That's what we did with Ethereum. It's likely what we'll do with Polkadot. So leaving potential bugs aside for the moment, then we need to be very careful with the mechanism in general. So one very simple governance mechanism is give Gav the key, right? And Gav will decide when Polkadot should be upgraded. That's basically, if we're honest, the Ethereum mechanism, right? Vitalik has the general key to Ethereum. If Vitalik says we'll upgrade Ethereum in this way, then aside from your Ethereum Classic 10%ers, Ethereum will pretty much be upgraded. We're not going to do that for Polkadot because it's not decentralized and it's not really,
Don't you want the key?
No, I don't want the key. There's far too much. With great power comes great responsibility. I don't want that responsibility. So, no. Rather, this is something that should be left in the hands of the people who are most exposed to Polkadot becoming good or bad, like Polkadot succeeding or failing. And as such, as the paper sort of pointed out in the first place, we quantify how much exposure you have to the Polkadot network success by the number of DOT tokens that you own, or that you at least have control over. And so the underlying means of making decisions within Polkadot of potentially upgrading or doing some out of bands arbitrary alteration to the storage, to the database, is through a vote that is weighted by the number of tokens that you control. Now, this is again tempered with a few other mechanisms, and will likely in the future be tempered with a few more in order to try to ensure that that malicious actors have a hard time pushing through something that is bad for the network. But it is also worth remembering that bad for the network is an extremely subjective term, and there's no way of ever having a single network that makes progress in a good direction while keeping everybody under the same roof. It just doesn't exist. Some people will never agree. And when it comes to a crunch point, either you don't make progress or one half forks off. And they can fork off as for all I care.
Is there, in some of those mechanisms, are you touching on quadratic voting? Is that not a thing? Is that too basic? Where are you at on that topic?
Quadratic voting has some interesting, potential. The really cool thing about it doesn't work unless you're Sybil resistant, and Polkadot has no intrinsic Sybil resistance mechanism because, hey, it's basically impossible. There are potential ways you can do it at a higher level, but when you're talking about the level that Polkadot's at, it's really not
And either you close it off to a known set of participants, or it's not Sybil resistant. Kind of like if it's completely anonymous participation, then how would you ever have identity? But so one thing that I like about this system and this design is that whatever structure we come up with today and make into like this is version 1 of Polkadot, there's no reason to believe that we will never come up with a better thing. And because we actually have this upgrade mechanism, we can upgrade to the better thing in the future.
Including the way voting happens.
Including the way governance happens. I mean, the governance system can be used to remove the governance system.
But going back to that, like having no one hold the key. Mm-hmm. So you're like, how would a community ever vote for its own voting rights? Or how would that happen? I guess based on percentages or the number of people who weigh in favor versus.
So the system that we have at the moment is not necessarily that which will be in the Genesis block. There's probably some iterations to come yet, perhaps fairly substantial ones. But at the moment, the system that we have is based around the idea of a referendum. So if you want to get something through, if you want to make a change using the governance system, and this can be a change, just a one-off change to the storage, or it could be an upgrade to Polkadot itself, then it must go to referendum. With a referendum, assuming everyone comes out and votes, you expect there to be more than 50% that vote in favor of the change for it to work. Turnout being what it is, it's actually quite unlikely that the whole of the stakeholder community will come out and vote. So in the case, if you get 50% plus 1 votes in favor of a change, the change goes through. Nothing will stop that, right? Majority carries always. If there's like full turnout. Even if there's like less of a full turnout, but you still get 50% plus 1 of the votes of the total stake in the system, it will go through. If you get less than 50% plus 1 of the total stake in the system voting for it, then, but still a majority, or indeed maybe not even a majority, then the decision is made dependent upon the council's approval of it. So the council is a body that is elected through approval voting. So again, this comes back to stakeholder weighted voting. But the council is a body that basically either makes it more likely that a referendum that does not have full turnout will go through, or at least elevates it to the level of a simple majority making it go through. If the council doesn't like a referendum, then it must go through the hard way, if it's to go through at all, which is that either you get everyone to come out, and that's a 50% plus 1. So basically the whole of the stake of the system votes, and at least 50% or slightly more than 50% votes in favor. Or you have substantially more yes votes than no votes. So you can basically overturn the council's disapproval by having a substantially greater number of yes votes than no votes. As you get closer to that magic 50% plus 1 yes votes, you need fewer and fewer, less and less of an advantage over the no votes. Once you hit that 50% plus 1, you need no advantage over the no votes. You've now got it because you've got 50% plus 1. So there's a nice little curve that you can draw. But at the relatively low turnout, you need an awful lot more votes than the no votes. So basically, a small number of no votes can prevent a change that the council doesn't think is a good idea from happening. And that's a means of avoiding, someone strong-arming the network into a change that not everyone thinks is a great idea.
I think as a bit of context, maybe not everyone is sort of involved in the blockchain space as deeply and like touching on these governance things, but I think any voting or like any governance protocol that depends on having high turnout is doomed to fail. Like if you're saying that if we get 100% participation, this protocol is perfect, it's sort of okay, but that doesn't matter because in reality, what we see with a lot of these like token curated registries and with a lot of attempts at governance right now, the average turnout is more like 2%, 5%. Most people just buy tokens and hold them and don't give a shit about what the project is because they're investors, they're speculators. So depending on having high turnout is obviously not super great.
I kind of want to ask some questions about you and your background. I had this question today, so I was wondering, how many blockchains have you built? I
built the vast majority of at least the earlier versions of the C++ Ethereum chain. And I was fairly heavily involved in the parity Ethereum chain. And I also am fairly heavily involved in the Polkadot chain and the Substrate code base.
And if not, directly programming on it very close to the parity Bitcoin implementation.
Yeah.
I think I'm very curious about what that process is like, building a blockchain. I know it's a little bit of a vague question, but...
It's much the same as, at least initially, it's much the same as many other projects. There's a lot of hacking around, there's a lot of bashing out code. But I guess one of the things where it differs a little is when you can finally kick off a testnet. And this usually happens in maybe 2 months, 6 weeks to 10 weeks after you've started your development. And it's pretty cool. Like, you can open it up to the public. You can start to get users. And by very virtue of it being a network where, people are sort of peer to peer, they're connecting with each other, they're asking, download, whether some particular version works or how they managed to get so many peers or configuration, all the rest of it. It's a little more community oriented than some other projects that you might do where you release and you get some users.
The question here is it designed, like in the design process, do you have to design more? Do you have to figure out more before you start releasing it? Or can you actually iterate like you do with normal software?
When I was building the sort of first version of Ethereum in, early 2014, there was definitely iteration there, but it was iteration done in tandem with Vitalik and Jeff. So for sure, we were designing to a large degree as we went along. We had Etherpads, no relation, that allowed us to sort of, collaborate in real time on specifications. And it was in fact the large Etherpad that sort of held all of the latest specifications as to what it was that Vitalik and I had chatted about that eventually turned into the yellow paper.
Oh, cool.
Right. So, there was one particular Etherpad was the EVM specification. And there were a few of the things like, I think, call or whatever that were a bit fiddly, a bit hard to get right. And, they weren't well defined in the white paper. So, after me and Vitalik had sort of figured it out between us, Jeff needed to know as well. And there were one or two other people who were sort of interested. So went in an Etherpad, I typed it all out, I maintained it. And that was pretty much necessary for writing a blockchain where there are multiple implementations.
And this is before testnet even.
Yeah, this was around the POC2, POC3. So there were early testnets, but they weren't, I think POC5 maybe was our really big testnet that sort of kept going for several months. So it was before then. It was in relatively early stages, maybe around February, March. And yeah, it was, it's notable that eventually more and more sort of, disambiguations got lumped in with the EVM spec. And one day it was like, I think it was early April 2014. It was like, right, I'm going to just put this into a paper because there's enough content now. It won't take that much. Which I did.
Who are the early people on those testnets? Like, did you know everyone who was participating?
No, there were some sort of, usual suspects, that sort of got in early and stuck around. I remember the prog guys, the People's Republic of Doug were pretty early, at developing smart contracts. And I heard, from people around that they, one of them at least, the guy who wrote some of those smart contracts still codes in LLL, which was basically the first functional smart contract language. And I mean functional as in you could use it rather than functional as in it was good. Yeah. So, there were a few for sure. There were some cool people that stuck around in the ecosystem.
So then on testnet, you were iterating, you were adding. What did you learn from like going through it that time to now? Like, do you feel like that creation part is different?
It's much the same sort of, fun of having people that, sort of using very sort of, excited about what you're coding and you're sort of putting new stuff in for them. There's not that much that's different. I mean, definitely there's more that's similar than what's different. It's a little different, I guess, in terms of with Ethereum, it was a smart contract platform. So you had more actual legit users rather than people who are sort of interested from a sort of early adopter DevOps point of view to try and understand what it takes to run a node. With Ethereum, you had those guys as well, but you had also the people that were like actually really interested in deploying smart contracts. And I hope that we'll get back as we start doing our first smart contract parachain. I hope that we'll sort of be able to start kicking around with those users as well.
So having built all these different implementations of different blockchains, like you mentioned earlier, there are some commonalities, obviously. What are the lessons, like broadly the lessons learned from having built these things?
So probably the biggest lesson was what happened with the C++ Ethereum and what happened with parity Ethereum, which is that you code it and, if you're a decent coder, you write things in modules and you try and be generic as much as possible. You try and be abstract, which allows you to iterate fast and sort of experiment and refactor relatively easily. And with CPP Ethereum, time came, I think it was probably early 2015, where it was clear proof of authority. There were people who wanted a proof of authority style network, so they weren't keen on mining. They had trusted or semi-trusted people, and they wanted them to be able to run a blockchain. And so there was already appropriate abstractions pretty much. So it didn't take too much refactoring in order to basically make it configurable so the same code base could be used for both the Ethereum mainnet and also proof of authority network. And then fast forward, we're doing parity Ethereum. And one of the first things that I did was I made sure that there was a generic way of configuring a network that allowed us to have multiple different consensus mechanisms be sort of pluggable. And it wasn't so surprising when later there was, lots of talk of pluggable consensus. No, we need pluggable consensus, says whoever it was, EA, I think. And it's like, yeah, we know we did that. I was coding that up 1 or 2 years ago, and it's been in parity Ethereum from the beginning. With Substrate, we go one further. And so this is the real lesson learned. With Substrate, it's not enough to have pluggable consensus. We want pluggable runtime. We want pluggable everything. We want to be able to make something that is 100% generic, but also really easy to develop on. And so, yeah, I mean, lesson learned from a life of coding is, be as flexible as you can. Don't be floppy. Don't try and literally, as you say, sort of work out the very best possible solution before you actually code anything. There is definitely a balance. It's important that you don't try to be over flexible, but you definitely need to push it towards the degree of abstraction, genericism and flexibility. And, that's definitely true for blockchain as well.
We haven't really described Substrate in any detail. What's the difference between Substrate and Polkadot, and how are they related?
This, in much the same way that, what I learned from CPP Ethereum, and when I started doing parity Ethereum, it's like, right, we're going to do it in this way because we want to be sure we've got pluggable consensus. In much the same way that I approached those, I came with that approach to Polkadot earlier still, and that's where Substrate came from. So Substrate is basically a necessary artifact, a necessary consequence of wanting to make things as generic as I could. So Substrate is in some sense parity's version of Polkadot. It's parity's version of what we call the Polkadot runtime environment, which is the bit of Polkadot that isn't the runtime. Right. So earlier I was talking about the runtime, which is the bit that's sort of the nature of the blockchain, the thing that makes Ethereum a smart contract platform, the thing that makes Bitcoin a currency. Well, the thing that makes Polkadot a parachain platform is the runtime. But if you ignore that and you just say, right, well, this is a platform that uses libp2p and WebAssembly in order to make a governable, upgradable blockchain, right? That's basically, other than that, just generic. that's Substrate. And it's also the basic idea, the specification of it, if you like, is also known as the Polkadot runtime environment.
So it's like a generalized framework for building blockchains. Do you have to use it with Polkadot? Can you only build parachains with it, or can you use it to like build your own thing completely separately?
No, it's wholly generic. So although if you use it, it will probably be fairly easy for you to turn your Substrate chain into a parachain. And that's the idea. That's the roadmap. But at the moment, it's really just a framework for building blockchains and getting them out and working really quickly. And it comes with a bunch of cool things like, you get automatic upgradability, which is not something that's generally available in blockchains at all. You get to use libp2p, which is relatively cutting edge. You get to use WebAssembly with the optimization that we have that basically makes it all run at native speed as long as you're running an up-to-date node. So there's a lot that's going for it. You basically get most of the technology behind Polkadot for free.
Would you call Substrate a toolkit? What is it?
Well, there's, if we go back to to the late 90s, early noughties, there were two main, things on Linux, that let you build GUIs. There was, Qt or Qt, as, the guys in Norway call it, but I think everyone else just calls it Qt. And there was GTK. Now these were considered toolkits. The T in GTK even stood for a toolkit. But Qt was positioned as a framework because you could use it as a toolkit. It had a toolkit sort of inside it, but the whole thing sort of taken together was a framework. I think the difference between the two is that a toolkit is like, it doesn't impose anything on you. There are just things in it that you can use and you just pick a few of them and use them and it's all good. A framework sort of says, right, well, you can't have it your own way from the top level. We tell you how everything's going to be sort of structured. And then within that structure, you work within it and you can add your own bits to it. So, whereas one is like, you add on, the other is like you take away. One is additive, the other is subtractive. And I think, Substrate is definitely more the subtractive thing. So it's definitely more of a framework. So it basically says, right, this is how the blockchain is going to be. And you can add your own components to it. You can remove some of the components. You can make it, you can sort of turn it from the inside into what you want. But from the outside, it's more or less going to look like Substrate.
Did Substrate come from, I think you sort of mentioned this, but was it like the fact that you wanted to create these like proof of authority blockchains? It was like from there that you got this idea of like being able to quickly spin up things. Was it from there? Is there a line from sort of the POA idea to this, or is it?
There is a line, but it's indirect. So the CPP Ethereum, one of the reasons that I made it more generic than it would otherwise have been was in order to support POA blockchains. And certainly one of the key design decisions that went in early on, like from day one of parity Ethereum, was to be able to support POA and eventually POS blockchains. So parity, one of the things it's working on at the moment, and Fred probably knows better than I do, but is a POS version of Ethereum. With POS obviously standing for proof of stake. And, that uses the same basic, abstraction mechanism that was put in on day one of parity Ethereum. And now, of course, it's not just, POA, POS, or changing all that. We actually want to change the entire runtime. So we're not just concerned with how new blocks are made or what finalization mechanism we're talking about, but rather the nature of the blockchain itself. Is this a currency blockchain? Is this a smart contract blockchain? Is this a name registration blockchain? Is this a parachain, an intercommunication blockchain? Or is it just some new blockchain that we haven't thought of yet that is yet to be invented?
Are most of the resulting blockchains from Substrate, are they usually proof of stake? Is there any, or is it really open? You can be anything. Or is it really in a POS space?
It really is very open.
Oh, wow. Okay.
It does have, at the moment at least, it does have a fixed consensus mechanism, but that is a next generation consensus mechanism that works very nicely. That said, we do eventually hope for even the consensus mechanism to become modular and potentially pluggable.
Wow.
The reason that that's not our priority right now is because A, we're really happy with our current consensus mechanism, and B, there are subtleties to modularizing the consensus mechanism, particularly making the network, giving the runtime, or the thing that can be switched in and out that currently is the runtime, giving it real-time access to the network. That is a massive potential security issue. And as long as it's running effectively sandboxed, which is what it does at the moment, because all it's doing is executing determining whether some block is valid and telling you what the changes are to the storage. As long as that's all it's doing, there's very limited damage that anyone could ever do to your computer. Mm. As soon as you say, okay, well, it's also going to define what the consensus mechanism is, and therefore which computers it's allowed to connect to and what it should be saying to them, then you've got and potentially also keys and, the whole thing vastly escalates in terms of seriousness. And it's not something we want to deal with. Other projects are attempting it, Tezos being a notable one. And we'll see how they get along.
That's it. I mean, you could build that on a layer below. So you're saying that, if you said that the consensus algorithm is not choosable at runtime, sort of you define it in your Genesis block and it's just hard coded into the client and it chooses the one that is configured from scratch and you can't change it, then it's obviously a lot easier to build around this. But you're still running into some considerations depending on how crazy you go with your consensus algorithm.
So earlier in this episode, we were talking about upgrading Ethereum, the sort of frustration that came when people were talking about sharding, but there was still a lot of kind of debate and work to happen. I think you've sort of answered it, but I feel like now that we understand a little bit more about Polkadot, about a lot of the ideas that you have, maybe you can say again, why not just upgrade Ethereum? Why not just build on that?
We certainly do plan on upgrading Ethereum when the time comes, and supporting that as best as we can. But it's a big job. It's a difficult job, and there are many different stakeholders that must all be brought into alignment over that upgrade process. And that's not something that we are positioned to be able to do. So in the meantime, and as it turns out, there's quite a lot of meantime, we wanted to bring that forward. Now, we could have gone one of two ways. We could have gone towards the keep as much as you can from Ethereum and kind of do the minimal set of changes in order to shard it. So basically, we could have done sharded Ethereum the parity way. If we were doing that, it seems to me that it would be unlikely for us to really put forward anything that would become successful, because eventually we would know for sure that there would be an alternative, incompatible version of roughly the same thing, from a bunch of other people that sort of more broadly represented the Ethereum community. So the alternative was simply to say, right, well, let's start afresh and let's build something that we think is not just a sharded version of Ethereum. In fact, maybe not in the slightest bit really a sharded version of Ethereum, but something that is perhaps technically similar, but that fulfills an alternative sort of niche or spot in the solution space. And that was just by far the obvious correct decision.
Do you think, will Polkadot work with Ethereum, with the shards? Is this all going to kind of be used in tandem?
Yeah, I certainly hope so. It's difficult to tell, of course, until we have the new Ethereum, which, as I say, is not something that's looking likely for a while at least. But given what we know of the direction that's going in, it does seem to me that the two will cooperate fairly well, and that the Ethereum bridge, which was always sort of noted to be a part of Polkadot, will be possible with the new Ethereum Shaspa edition. That's sharded Casper, and not anything else that begins with sh.
I kind of like that. It's sort of, it actually sounds like, you're sort of bringing two projects that you initiated potentially back together somewhere down the line where they become connected and maybe serve slightly different purposes, but actually can work together.
Yeah, that's right. I don't see them as being in a huge amount of competition. I think by and large they serve different purposes. The Ethereum network is really about ensuring it's geared towards smart contracts. Its level of abstraction is very much at the user sort of level. It's the sorts of programs it handles are sort of small snippets that benefit hugely from being in the same environment as other small snippets of code. Polkadot's rather different. It's the abstraction that it works around is chains. So we're talking about high volume, one or very few levels of fixed functionality, where interoperability between these pieces of fixed function, high volume pieces of fixed functionality is relatively small. That said, I do think, there will be some degree of interoperability that happens within the Ethereum network, and I think there'll be some degree of smart contract provision that happens within Polkadot. But I think, nonetheless, by and large, they're going to be pushing in different directions.
So I want to say thank you so much for sitting down with us, going through all of this.
Not at all. Thanks for having me.
We have wanted to have you on before. I'm so glad that we got a chance to do it. To our listeners, thanks for listening.
Thanks for listening.